Welcome back to Hello Agrarian channel. I am Dr.t. Pandiaraj, working as Assistant Professor, Department of Agronomy, College of Agriculture, Ajamgarh. In this video, we are going to see solar radiation. Sun supplies virtually all the energy received by the earth. Solar radiation is the source of energy for all the process taking place on the earth's surface, which includes evaporation, transpiration, hydrological cycle and precipitation and all other physical phenomena. So how does this energy forms in the sun? So there is a question there. So how this much amount of energy producing in the sun? If you look at the sun, the energy comes from the sun itself. So the sun generates a massive amount of energy from a process called nuclear fusion of hydrogen nuclei into helium in a plasma state. So the sun generates the energy from a process called nuclear fusion. Okay. So in this process, the hydrogen nuclei convert into helium in a plasma state. Hydrogen nuclei convert into helium in a plasma state. So if you look at the sun has 90% hydrogen, 9% helium and 1% other elements. So these are the major composition of sun, that is 90% hydrogen, 9% helium and 1% it is other elements. So this can be written as in equation so 4 helium plus 2 nu plus 6 gamma. So this convert into temperature, the energy is approximately 26.7 mega electric voltage. Okay. So this much amount of energy produced in the sun. So you see here, one day produced energy in a sun can be utilized for 1 year for the earth all the activities. So this much amount of energy produced in a sun. So here in this reaction, the 4 hydrogen nuclei along with the 2 electron convert into 4 helium, 2 nu and 6 gamma rays. So it is convert into energy. So 26.7 mega electric voltage produced in a sun. So here there is a word, it is called plasma state. So plasma state, it is a state of materials. So there are 4 fundamental states. One is solid, liquid, gases and plasma. So plasma states, it is you can say it is high heated status of the gas. It is high heated status of the gas. So in this state, the atom separated from the ion. Okay. So there is a state called plasma state. So this plasma state more prevalent in core part of sun. So what is plasma state? We know there are 4 fundamental states. One is solid, another one is liquid, third one is gas, and the fourth one is plasma states, isn't it? So this plasma states is an electrically conductive medium in which equal number of positive and negative charges produced when the atom in gas become ionized. So that is called plasma state. So this plasma states occurs when the body has more temperature, that is extreme heated states. So that condition, any atom separated from the ion, isn't it? So this is called plasma states. So this process occurs in a plasma states. So if you look at the sun, it has an interior zone and another one is an atmosphere zone. The sun has, first one is an interior zone and second one is an atmosphere zone. So these are the two different zones in the sun. So whereas in interior zone, it has three parts. First one is core parts, second one is radiative zone, and third one is convective zones. So these are the three different zones in the interior zone of sun. So this is a figure of sun. So if you look at this core region where hydrogen nuclei fusion to form helium, hydrogen nuclei fusion to form helium. So and it produce immense amount of energy here. So the energy is generated by thermonuclear reaction creating extreme temperature in this core region. So once energy formed over the core region, it slowly come to radiative zone. So this in this radiative zone, so all the energy move in different direction. So this is a radiative zone where the energy move to all the direction from the core parts, and this region is called convective zone. So where convection process taking place in this region. So in this convection process, the heat first rise to upper parts and then come towards inner parts. So this convection process cause the repetition of temperature around these convection parts. So because of the colder region available on the surface of this outer region of sun, the temperature first rise to this upper boundary, then return to lower parts. So this is all about three parts of sun. So core region, so the energy principally formed in this core region. Once the energy formed over this core region, it come outwards, that is into radiative zone. So in this radiative zone, all the energy goes to different direction. Then third one is convective zone. So where convection process taking place in this region. Okay. So this is all about the interior parts of sun. So once you come out of the come out of the sun, there you can find the atmosphere zone. Here again there are three parts. One is photosphere, chromosphere and corona. Okay. So this is called photosphere and this part is called chromosphere and this region is called corona. So these are the three exterior parts of sun: photosphere, chromosphere and corona. So the photosphere, so the sun energy is released as a light. Okay. In the photosphere, the sun's energy released as light. Okay. So this is the first layer where light can be visible. Then second one is chromosphere. In this zone, in this chromosphere, the color is mainly the red color is mainly due to the this chromosphere. And next one is corona. So in this region, the temperature may goes even up to 10 lakh degree Celsius also. 10 lakh degree Celsius also. Okay. So these are the exterior parts of sun, that is inside the atmosphere. So photosphere, chromosphere and corona. So the temperature you see here, in photosphere the temperature may be around 6000 degrees Celsius, and in chromosphere, so I can write here, in photosphere the temperature is around 6000 degree Celsius. In chromosphere the temperature will be 10,000 degrees Celsius, and in case of corona the temperature can rise up to 10 lakh degree Celsius. Okay. So this is all about sun, both interior zone and atmosphere zone. Okay. So I hope you are clear about these sun parts. The next one is, how does the sun energy travels through space? How does the sun's energy travels through space? Okay. So as I told you, the sun produced immense amount of energy in the core parts. So once energy produced in a core parts, then it moves to radiative zone and it comes to convective zone. So from this convective zone, slowly the energy comes to the space in the form of radiation. So the energy comes to the space through radiation. Okay, so through this radiation only the energy travel through the space. So this radiation comes in the form of wavelength. Okay, so for full understanding this wavelength, we must know electromagnetic waves, that you might have seen this kind of electromagnetic waves. Okay, so this is called electromagnetic waves. There are three axes, y axis, and this is z axis, and this is x axis. Okay, so this upper parts is called electric field, and this lower parts it is magnetic field. So in any wavelength, so this electric and magnetic field passing at a constant light speed. Okay, so this slope is called light. Okay, so both this electric and magnetic combinedly called electromagnetic field. So this electromagnetic field travel in a sinusoidal fashion. Okay, it travel in a sinusoidal fashion along through the light speed. Okay, if you look at this electromagnetic wave, so there is one crust, okay, and the lower one is trough. Okay, so one is crust and the upper parts. Okay, this upper parts is crust and lower parts is trough. Okay, so any distance between any crust part, that is called wavelength. Okay, so wavelength means it is a distance over which a wave repeats. Okay, so wavelength means distance over which a wave repeats. Okay, so it is a distance over which a wave repeats. So this repeating wave is known as wavelength. Okay, so it is represent as lambda. So this wavelength carrying the energy through a medium, just like space, vacuum, or even in ocean also. Okay, and there is one more thing, that is called frequency. So you can say the frequency means the number of peaks passing in a unit time. Okay, frequency means number of times number of times the peak wave passed in a time. So this is called frequency. So if more number of peaks passing in a certain time, so that is short wavelength. Okay, so there are two kind of wavelength. One is short wavelength, another one is long wavelength. Okay, so one is short wavelength, another one is long. Okay, so another one is long wavelength. Okay, so based on the wavelength, it can be two types. One is short wavelength, another one is long wavelength. Okay, so I can delete these things. The light is categorized into wavelength, and the second one is frequency. So this wavelength, frequency and speed of any medium can be written as in the equation like V equal to lambda F. Okay, so in case of light, the V can be replaced by C. So C means light. Okay, so C equal to lambda F. Okay, so the longer the wavelength, the lower the energy. Longer wavelength, lower energy. Okay, so for an example, suppose initially if you look at the electromagnetic spectrum, the wavelength starts from short wavelength, then it continues to longer wavelength. Okay, so in the longer wavelength the energy is lower, and whereas this short wavelength it produces more frequency and more energy. So these characters can be written as E equal to H C wavelength, or you can write as E equal to H F. Okay, H F. So where E is energy, so this H means Planck constant, that means 6.6 to 6 into 10 power of minus 34 joules second, and lambda it is wavelength. Okay, C is speed of light, okay, speed of light. F means frequency. Okay, E means energy, H means Planck constant, that is 6.626 in 10 power of minus 34 joules per second, and lambda that is wavelength, C means speed of light, and F means frequency. So this is all about the how does the solar energy travels through the space. If you look at any hot substance, it produce more short wavelength, and cooler body produce more longer wavelength. In case of sun, it produce more short wavelength once reach on the earth surface, and this radiation convert into long wave radiation. Okay, so the temperature is inversely proportional to the wavelength. So solar radiation is a renewable energy. Solar radiation is one of the best example of renewable energy. So right now we have discussed the different parts of sun. So this is core parts, and this is radiative parts. This is core, and this is radiative, and this is zone part. So this is convective zone. Okay, so these are the three different parts right now we discussed. So once energy produced in this core zone, it slowly come to the radiative zones. So do you know how long years takes the energy come to radiative zones? So it is around 1,70,000 years. Just imagine. So this much year, that is 1,70,000 years takes for energy comes to radiative zone. Okay, because this core parts, okay, so this core parts tightly packed in the sun. So the energy cannot come in any fraction of seconds. So it take too much years. So it take about 1,70,000 years to reach in this radiative zone. So there is one more question: how long does it takes sunlight to reach the earth? So do you know, anyone know how long does it takes sun radiation reach to the earth? So it takes 8 minutes 20 seconds. Okay, so the solar radiation takes 8 minutes 20 seconds reach to the earth surface. Okay, so once the solar radiation come to the convective zone, so from here to earth just take 8 minutes 20 seconds. Okay, so I can draw here also. Suppose this is sun and this is earth. Okay, so the distance between sun and earth is around 150 million kilometer. Okay, 150 million kilometer. If you say in miles, it is 93 million miles between sun and earth. Okay, so you see, this is average distance between sun and earth. So it may vary from season to season. Okay, not season, the rotation period. Okay, so there is two kind of rotation period. One is aphelion, okay, one is perihelion, and the second one is aphelion. Okay, so these are the two different rotations occurs around that is distance between sun and earth. So in perihelion it takes around 147 million kilometer, and aphelion it takes around 151 million kilometers. Okay, that means during perihelion period the earth comes closer to the sun. Okay, during perihelion period the earth comes closer to the sun. It takes, okay, so not too close, it is around 147 million kilometer distance. And during aphelion period, okay, during aphelion period the earth goes away from the sun. It is not 151, it is 152 million kilometer. Okay, so during aphelion period the distance between sun and earth is 152 million kilometers. So if you take this average, okay, if you take this average, it comes around 149.5 million kilometer, or we can say in round that is 150 million kilometer. Okay, so the average distance between sun and earth is 150 million kilometers. Okay, so we said the sunlight takes 8 minutes 20 seconds to reach on the earth surface. So there is a calculation, okay, you can derive this one also. Suppose you see the sunlight, okay, the sunlight move at a speed of 3 lakh kilometer per seconds. Okay, this is speed of sunlight. Okay, the speed of sunlight is about 3 lakh kilometer per seconds. Okay, and the distance between sun and earth is 150 kilometers. Okay, so this you can divide it. So 150 million kilometers divided by 0.3 millions. So this 3 lakh you convert into million, so you will get 0.3 million. Okay, so you will get around 500 seconds. Okay, so this 500 seconds you convert into minutes, so that is 8 minutes and 20 seconds. Okay, so you can say in 500 seconds or 8 minutes 20 seconds that solar radiation takes reach to the earth surface. Okay, so in this way the sun energy travels through the space. I hope you all clear so what I discussed over here. So next one is that what kind of solar energy comes from the sun. So what kind of energy comes from the sun. Okay, you see the sun emits many forms of electromagnetic waves in varying quantity. So initially it starts from short wavelength, then increase the long wave length. Okay, so it is mainly in the form of electromagnetic radiation. Okay, so initially it comes in short wavelength, then it continues in long wavelength. Okay, so right now we discussed, so the sun, because of having high temperature, it produce more amount of short wave radiation. Okay, so likewise, okay, so this short wave length, if you see in electromagnetic spectrum, okay, so which are having like this, suppose, so this is visible light. Okay, so this portion is called light, and this is UV radiation, and this is X-rays, and this portion is called gamma rays, gamma rays. Okay, so this up to the light, okay, up to the light band, it is called short wave length. Okay, and above the light portion, it is infrared region, infrared. Okay, and you can say thermal infrared region. Okay, thermal infrared region, and likewise radio band. Okay, so then microwave, so likewise. Okay, so these are the short wavelength, because their energy is much higher as compared to followed by band. Okay, so we discussed already, the short wavelength produce more frequency and more energy. Okay, and whereas in light, the light contains 7 different colors Vibgyor. So you all know, starting from violet, indigo, blue, green, yellow, orange and red. Okay, so these are the 7 different colors, or you can say these are the 7 different spectrums or light produced in the portion of light. Okay, so this light portion, the wavelength between 400 and 700 nanometer. Okay, nanometer. Okay, so the band, the wavelength of light is between 400 and 700 nanometers, and this is above the 700 nanometers. Okay, above, so beyond this light, it is all above, beyond 700 nanometers. So you see, only visible light reach to the earth surface. Okay, so what we are getting the light, it's all about this the wavelength between 400 and 700 nanometer. Okay, so for example, if 100% of light reach on earth surface, so 43% is visible light, 7% is ultraviolet radiation, 49% of infrared radiation, and 1% as a gamma rays, X-rays and radio waves. Okay, so I can write here also. So out of 100% light, okay, out of 100% light, so out of 100% light, visible light is 43%, and ultraviolet radiation is only about 7%, and infrared about 49%, and X, gamma and radio waves. So, these are about 1%. Okay. So, this most of the ultraviolet radiation absorbed by stratosphere, where the ozonosphere there. So, this ozone molecules absorb this ultraviolet radiation. Okay. So, most of the ultraviolet radiation absorbed by ozonosphere, and this X-ray, gamma rays. So, this all absorbed in ionosphere. Okay. So, okay. So, this is a proportion of the light which are reaching on the earth surface. I hope you all understand about this solar radiation. In this video, we discussed how the energy generated in the sun and how this energy travel through the space and what kind of energy comes from the sun. So, if you have any doubt, you can comment on the box. Thank you very much.